Welcome to the session titled How JP Morgan Chase and LexisNexis are modernizing analytics with Amazon Redshift. My name is Manan Goyal. I'm a principal product manager with the Amazon Redshift team. So I'm part of the team that's building Amazon Redshift, our cloud-native data warehousing service. Today we have a real special treat for you. We have two of our customers who are going to talk about their journey in terms of how they are modernizing data warehousing with and analytics with Amazon Redshift. So in terms of the agenda for today, what we're going to talk about is I'm going to kick things off, just provide some broad context in terms of what we are hearing from customers around data and analytics and how Redshift helps customers manage the explosion of the data that customers are seeing. We'll talk about, then I'll bring in Anand from JP Morgan, and he's going to talk about how they modernized analytics within their environment with Redshift. And then we'll have LexisNexis come in. And towards the end, we'll have some time for questions and answers as well. All right, so just to kick things off, I'm sure the explosion of data is a trend that pretty much every customer across every industry, each one of you are seeing in your organizations. We've been hearing about it for quite some time. The volume, variety, velocity, veracity of data just keeps expanding. I have a quote here from IDC and Seagate, where they're talking about how quickly the data volumes are growing. So much so that in 1 hour now, in the time that we spend together over the hour or so, more data is going to be generated than it was generated in an entire year, just a couple of years ago. So needless to say, there's a lot of data coming around. The volume of it, the velocity of it, the veracity of it, the forms of it just continuously keeps expanding. And this represents both an opportunity as well as a challenge. So in terms of the challenge, imagine if you don't have the right infrastructure and technology to manage this data, then you can experience a number of challenges your performance can become sluggish or slow. Or, there are things like security breaches, how do you manage this data? Do centralized governance, security, compliance around it, that could become an issue. And definitely there are things around cost overruns, with the explosion of data, how do you cost effectively with the right price performance, store it, process it, analyze it, and get value out of it. But on the flip side, think of it, imagine if you had the right infrastructure and the technology to manage this data, what a phenomenal opportunity it is. With all this data that's coming around, it's a great opportunity for you to learn more about your customers, understand their behavior, and dramatically improve customer experiences, if you will. You can also design new products and services. We've been hearing a lot more about data as a service use case, sharing data, collaborating around data. So phenomenal opportunities to build new products and services with all the insights that we are gaining from data. And then definitely outsmarting your competition in terms of delivering better customer experiences, optimizing your business processes, and doing more and more with the data. But the key linchpin here is having the right technology and infrastructure to manage the data. And that's where Amazon Redshift comes in. So for those of you who are not familiar with Amazon Redshift, Redshift is Amazon's cloud data warehousing service. It gives customers like you the ability to bring anywhere from terabytes to petabytes of both structured as well as unstructured data together and analyze it with scale and performance. It gives you the ability to run complex SQL-based analytics on top of this data. And as we the service has been around for a couple of years, and as we work on expanding the service, we always work backwards from customer requirements. So primarily for Redshift, our cloud data warehousing service, the innovations that we are making, I'm sure you heard some announcements, in some of the keynotes and other sessions that you'll hear today. The innovations or the new capabilities are being launched in three main areas. The first one is giving you the ability to analyze all your data. So what Redshift does really well is give you the ability to go across, if you have transactional databases in your infrastructure like Aurora or RDS, or data warehouses like Redshift, or you have your data lakes like Amazon S3. Redshift gives you the ability to seamlessly go across this data. If you want to leave it in place, you can leave it in place, access that data through features and capabilities we provide, things like data sharing, things like federated query, giving you data lake queries as well. So you can go analyze this data in place. And then definitely, from a performance perspective, if you want to bring all this data in Redshift, take advantage of, Redshift's columnar data storage, analytics processing. We also give you capabilities there. So a couple of announcements that we made this week. We announced zero ETL between Aurora and Redshift. So it's a seamless integration where Aurora data moves into Redshift and you can do analytics on it. So integration between transactional databases and data warehouses, plus other things like auto copy from S3, so moving data from S3 into Redshift. And then we also announced a couple of partner integrations with Informatica and things like that. So one key pillar of investment which we are making in terms of product capability is this, giving you the ability to go across data wherever it resides in your environment, whether it's data warehouses or databases or data lakes, and analyze that data in place or move it around if that's what you want for best performance. The second key area of investment for Amazon Redshift, right from day one, has been price performance. When we launched Redshift 10 years ago, that was one of the biggest things that we heard from customers. Is they found that the cost and the performance they got with traditional legacy data warehouses was just not something that they could work with. So price performance has been a key investment area for Redshift from day one. We continue to launch new capabilities. We continue to run benchmarks. And what we see typically with Redshift is, for dashboard type workloads where you're doing query reporting and analysis, short queries, there are a lot of capabilities, features in the product, things like, automatic workload management or automatic materialized views, concurrency scaling, which gives you unlimited concurrency for users and workloads. That gives you up to 7x better price performance compared to any of the alternatives in the industry. In general, for your traditional workloads, what we continue to see is up to 5x better price performance. So when it comes to price performance, Redshift continues to we continue to invest in that area, give you more and more capabilities to make it easier, more manageable for you to run the data warehouse. And then the final thing is around ease of use, security, reliability. What we hear from customers like you, data warehouses are becoming more and more mission critical applications. Availability is really important. Ease of use is really important. Security is really important. So that's where earlier at last reInvent we had announced Redshift serverless, and we made it generally available this year. And it has been a really popular release for us. Thousands of customers every month use Redshift serverless. We also announced a couple of new capabilities this morning, like multi-AZ support for reliability. And from a security perspective, we have features in Redshift all the way from authorization, authentication, encryption, common things like row-level security, column-level security, data masking, and all that's available to you. As a result of all of this, what we see is tremendous adoption from customers as far as Redshift is concerned. Every day, tens of thousands of customers across every imaginable industry across the globe use Redshift. So whether it's media and entertainment customers like Electronic Arts or Zynga, or financial services customers like JP Morgan or Goldman Sachs, or born in the cloud companies like Pinterest and Peloton. Wide variety of use cases, wide variety of customers across all industry verticals. From a use case perspective, what we see is like, anywhere from self-service analytics, dashboards, reporting, query analysis, to real-time analytic use cases where you are tapping into streaming data coming from Kinesis or Kafka, doing analytics on top of it, or more advanced data science and machine learning type use cases where you're doing predictive analytics, to also like data sharing and collaboration type use cases where you can share data not only within your organizations but across your organizations as well. All right, so with that, what I would like to do is to invite Anand Singh to join me here on stage. Anand is Executive Director at JPMorgan Chase, and he's going to take us through their journey in terms of how they modernized analytics with Redshift.
Thank you, Manan. Scale, that breaks everything. If we can draw a parallel to software world, the challenge of scale is at the front line and one of the most pressing challenge. And those are the hard and complex problem, day in and day out, we as data engineers, cloud engineers are trying to solve. And it has been very succinctly put by Werner, CTO, scale breaks everything. Yesterday, you might have been part of the keynote by Adam, and he spoke a lot about data, immensity of the universe, and so vast is the data universe. So that's going to be the core theme which we are going to talk about in this session. So there are three things which we are going to cover. First, from our experience, how scale hits us. How did we navigate that change in JPMorgan? And hopefully we can leave you with some of the learnings which you can apply. Obviously, it's a 15-minute session, so we won't be able to go into the finer details of every technical details, but I'm happy to connect with all of you post this session outside the hall so that we can strike a conversation, understand about your journey, how you have been trying to solve these problems. And hopefully that will be a mutually learning experience for all of us. So if we talk about JPMorgan, we have 200 years of history built on trust. It's our customer who are front and center of everything. In good times and bad or highly volatile time, we got to support them. And those are the times when the scale is very high. So it's very important for us to make sure that we are trying to build that scale for the benefit of our customers and clients. And if we look at the hyperscale at which we operate, we have almost $33 trillion of asset under custody. We have $10 trillion of payment going through our pipes every day. 40 billion events are hitting us every day. That's the scale which we are talking about. We do business with more than 90% of Fortune 500 clients. Their liking, their preference, their propensity is going to define how we innovate and do the business transformation. If I think about technology, it's a big responsibility. However, I also see it as a tremendous opportunity for us at JPMorgan because we have $12 billion to back it up. We have 500 petabytes of data, north of that 500 petabytes of data. So there's a huge amount of data which we have already. We want to make sure that how we can use this data and try to mine that gold to come up with differentiated analytics for our clients. Now, I am part of CIB Market Sales Technology, and I would like to quote our leader, Mark Badeshani, who always says that we have to serve our clients end to end. What it means is that last year we had just shy of $32 billion of revenue. Now, trade execution is a snapshot of time, But what is more important is pre-trade. What is even more important is post-trade, because that's where we get the stickiness. It's that end-to-end serving which makes it really one-stop shop. What it means is all that data has to be as a hyper-connected data fabric, and we should be able to apply analytics to get those actionable insights for our sales so that when they are on the road, we should be able to crunch all that data and make it available to them. Because think about Amazon. If you order a book, it's going to show up at your delivery, completely connected system, and that's how we need to be operating. So the biggest challenge, and the platform which I'm going to talk about is XIB, because that's the one-stop shop for all the salespeople in CIB. And we are talking about more than 2,200 salespeople. They need this platform for decision support. And we are going to talk about how we have taken that into the digital transformation journey. So if there's one slide which I would like you to go back with, it is this slide. Because we are going to talk about the problem domain where we used to be and how exactly we have come up with the solution architecture to navigate that problem. So first of all, obviously the scale. Let's talk about it for a bit. I always think of it as a drip. Data rich, information poor. So it's very important for us to make sure that we are getting the right information and insights. And typically, far too long, we have been operating in a world where we put all that data for analytical purposes into data warehouses from all the operational stores. And the way typically the licensing works is, it is by how much of data you can store. That's very limiting. The moment we start coming close to that threshold, we start flooding out. That's not the way to operate. And then with dawn of big data, there is a lot of unstructured data which is coming to us. Think about audio, video, conferences, email, chats, Bloomberg. There are n number of touch points for us to interact with client. We want to mine that data because there's a wealth of information which is lying there. So as a part of modern data architecture, it was becoming even more untenable. And what we wanted was to make sure that all of that data comes together. We should be able to synthesize all of it flawlessly. And that's where we have been operating and using lakehouse architecture, because you can have your purpose-built databases. You can have operational stores. You can have data lakes. And you should be able to connect. It's like a connecting tissue. You should be able to synthesize all that information together. That's really powerful. And then with Redshift Spectrum, which comes for a ride if you have Redshift cluster, gives you capability to have a view not only with the model data in Redshift, but also you can have data lying on your S3, and you should be able to combine that data to gain insights. So that's like really, really powerful. Now, the second thing which I want to talk about is architecture simplification. Keep it simple and stupid, yes. And that is very important because we had a very convoluted architecture, which I'll go in a second. But what we did was we used Redshift as an all-in-one data pipeline. And it was really has worked wonderful for us. Now, we started this journey, and sometimes it takes like too long. We started this journey 2.5 years back. And at that point of time, we also tried with Spark SQL, but obviously with Spark 3.0, we have got adaptive query execution. It was not there at that point of time. And also the very nature of the problem which we're trying to solve made some modification into the historical data, so it was not really working very well. But with Redshift, we have been able to get that performance. So basically, we are using Redshift all through. Right from ingestion, trying to do the ELT, and then finally getting into the reporting layer, and also getting insight right at the top of Redshift. So that simplification has really helped. Now, one feature, which is, I think, the future in the next 5 to 10 years is autonomics. That's like self-driving cars. I mean, we always try to do the best design with our data stores. Like Redshift, if I think about it, it's a columnar database. You can try to distribute that data so that all the nodes are working in parallel. So obviously, you will try to make sure that the distribution is accurate, and it has a very high cardinality. If you want to do a sort, it has to be with the low cardinality. Even for distribution, you want to make sure that you're distributing. So all your fact becomes the key way of operating so that you're spreading that data out. If you're trying to make sure that all the dimension tables, so I'm talking typically about the star schema where you have the facts, and then you have the dimension at the top, how you are trying to make the reporting. So that all goes as all. And even is somewhere in the middle. So that's the way you distribute that data. But that's like too much. You're trying to get into the details of it. And when you try to run it, you can't predict the pattern of query. So query will go in a very different direction. Then you can actually have materialized view with a different sort key or a distribution key, which you can have. But then that's how you start having more ways of operating so that you can optimize the queries further. What if everything can be done for you? It's like it comes back to you and says, OK, why don't you go and take a nap in the backseat of the car, and I'm going to drive that car for you. Very, very powerful. And that is what we have seen, because they can actually, if you go into the auto mode, they can actually find the right design for you. They can constantly change it. They can make a materialized view. They can auto-refresh it and make sure that some of the queries are picking those materialized view. All of it is happening behind the scenes seamlessly. And that is one thing which we really liked, because that becomes your trusted ally in a big way. So that was really very, very helpful for us to focus on value-added stuff. Because you must have been like coming from the world, because we always talk to SA and DBAs and trying to optimize it. But this is something where it is using machine learning to really do that for you in a very, very self-pilot mode. So that's very important. And then, obviously, in terms of performance, as Manan spoke about, there are so many things which has been done. So we operate in one cluster, and there are a variety of workloads. The sales application want to access the data in 2 or 3 seconds. There are some batch operations going on. There are some queries going on. Enterprise reporting is also happening at the top of the same cluster. So the workload isolation and trying to prioritize those queue, and then everything is being taken over by Redshift has really worked well. Because with that, we also get short query acceleration so that it doesn't really sit behind the long ones. We also have monitoring rules which make sure that nothing hogs your system. So that's very important too. And then the concurrency scaling is a feature which was spoken about, and that we use quite a lot, because this runs every day. So we get 30 hours of credit, and that is something which we use to make sure that it can spin the cluster for you, and it can tear it down. So any spiky workloads, you don't have to suffer from the performance perspective. So that's very important. And then last 2 points are very important from financial perspective. We want to make sure that data governance is very important. It doesn't slow you down, but you have the policies in place. As code, you have the granular way to entitle, because salespeople would definitely be very, very concerned about it. And then the last but not least is being a good cost custodian. We want to make sure that we are having the good way to make sure that we are saving some dollars for the firm. So we have gone with 3-year RI, and that has been really helpful for us to amortize that cost over the next 3 years. You can always make sure that you have the hot and cold data. So you can model the data which you require in Redshift, but most of the cold data can go to S3. You can define those lifecycle rules further so that they can go to cold storage. So that, if we do it properly, then we are able to save a lot of cost. Now, I just want to talk about our journey to AWS, because in 2015-16, that's when we started having a purposeful exploration in JP Morgan as a financial firm to start thinking about cloud, how we can go to cloud. And at that point, the regulatory landscape was still emerging. There was slightly less trust. And in 2017 is when we went with the first bold pursuit of trying to take 2 applications across the entire bank to cloud. And XIB, which I'm talking about, is one of those applications. Because they had so many data locality rules by many countries, it was not optimal. We were not able to aggregate that data because some of that data used to exist on-prem. And that didn't work for us. We had to take a step back. We had to pull off. And then finally, we took 18 months of transformation to make sure that we re-architect our system. So sometimes it has to be lift and shift. For some use cases, it could be rehost. For some use cases, it has to be, you have to re-architect to really exploit the full potential of cloud. And that's what happened with us. So the only thing I would like to say is that, it's more like success is a journey, not a destination. And we have to really calibrate ourselves, repivot, and make sure that we are learning constantly and getting to the destination. So that has been really the mantra with what we have been operating. Now, so if I'm talking about the outcomes, this has not been possible without the help from AWS. That has been really a very close partnership. We have been working with them day in and day out. And apart from the technical aspects of going to cloud and the advantages which we get, we really wanted to look at it from the business lens. What are the business tangible outcomes which we are talking about? And I want to mention two. First, the information available to all our sales force by a few hours early makes a huge difference. It's a force multiplier because that time can be taken by all those people as more airtime with the clients. And the second is you're able to run those machine learning models right at the top of Redshift by its connectivity with SageMaker. So you're trying to segment the client. You're trying to look really as how you can do the personalization. And those are some of the possibilities which we are trying to unlock with Redshift. Now, on the right-hand side, I really want to focus on one thing based on our learning out of this large-scale complex migration. Obviously, you need to have a very solid enterprise tooling to be available for a bank to migrate the workload faster. Resilience is very important, and what we have done with resilience I will cover in a second. And the governance and security we spoke about. But what has been really important is the skills of the future. Investing in the human capital, that's the make or break. And what we did was we really tried to double down on our certification to make sure that our people are getting that right knowledge because they have the best context in terms of their understanding of the platform, the business. And if we can really take them to that journey of learning those skills, that has really worked wonders for us. Now, in terms of the architecture, a couple of things I really want to mention about. We live in a hybrid model right now. So there are a few applications which are on-prem, and we have gone to AWS with most of the compute and reporting. Some of the reporting are still on-prem. So it's very important for us to make sure that they are really connected. So for example, anything which is on-prem is connected via direct connect link, which is very fast without traversing the internet. But also we want to connect with all the VPCs via transit gateways so that they are connected with each other. And also from Amazon perspective, we are going via VPC managed endpoint. Initially it was going through, and that is very important because it uses the private link, so you don't have to traverse from the internet. And from resiliency perspective, it's very important because if something happens, then the cluster is able to relocate flawlessly behind the scene to another AZ. And that is only possible with managed VPC endpoint. We don't want to have IP address of the leader node and then make the client repoint to the new one. So that becomes a very flawless journey. The second thing which I want to talk about is as we move a lot of data, data gravity is another thing which becomes very prominent. Because if your data is going to be in cloud, slowly the applications are also moving to cloud. All the reporting is also moving to cloud. So it becomes important for us that the way we interact and share the data in JP Morgan via the data mesh, and there is a big blog if you're interested. But the whole point is, as a domain expert, you are owning your data. You are owning your data product. And you are making sure that that is available via the central lake formation, which itself can be federated at various levels. It could be at the LOB level. It could be at the enterprise level. And we share data with each other without any copying. And that makes sure that some of the anti-patterns of data gravity is also taken care of. Data mesh is a way to connect. It's kind of the connecting tissue. But also, if there are Redshift cluster, we have been actively using data sharing so that if you want to do some calculation between sales and marketing or profitability needs data from revenue to calculate that, they are able to access those clusters and talk to each other. So that's important. And the last thing is everything as a code. That is something which we have started right from day one. Infrastructure as a code, policy as a code, and it is all connected via the CI/CD pipeline so that any changes happens, they are well audited within the control plane of JP Morgan, and we are able to get that scale with confidence. Now, I've spoken a lot about performance, operational efficiency, and being a good cost custodian. What are the things which we have done? But in terms of programmatic integration, we have really worked together with AWS to make sure that, for example, the sequence number, that's something which we are still working on. And we use an identity column right now, but that's something which is coming, and we are still testing with JP Morgan, with AWS. Now, global temp table, just to make sure that we are able to parallelize, because we do a lot of ETL. Hopefully, as per yesterday's keynote, when all the Aurora Postgres are able to connect with Redshift, hopefully we can get into the zone of no ETL or zero ETL. That's still a dream. And some of the copy command with more parameterization to make sure that we can actually further improve and optimize. But what is more important is the future, looking towards the future. Serverless, that's something which we definitely want to go for. We want to make sure that the current way of failovers is to a different AG, and we want to make sure that we are working with AWS to see how we can be cross-regional. So that is another aspect of resiliency which we are working on. And from insight perspective, AIML, you can run those because of the connectivity of Redshift with SageMaker. But what is very interesting, which was spoken yesterday, was about Spark. So you can actually use Spark to directly talk to Redshift. And there is a lot of code which the data scientist group, they are writing in Spark for those complex use cases. So that is another thing which we are looking forward to. And then at some point of time, we want to make sure that we can do some forecasting with Q at the top of it, with its connectivity to Redshift. Data exchange is another thing which we want to look at, because we would like to commercialize some of the data products, and that is going to be very handy. And then from security, last but not least, with data zones, that's something we definitely want to look forward to and see how we can really use data zones from our perspective to make sure that it becomes a way to distribute data and have a layer of control plane sitting at the top of it. So with that, I would really like to thank you, and glad we are all here. And obviously, if you have any questions, we'll be taking it towards the end, or maybe after the session. But thank you very much. Thank you.
Thanks, Anand. JP Morgan has been a great partner for us in terms of really excited about what they have done with Redshift, and also look forward to working with them in the future in terms of how they're going to leverage some of the new capabilities that are coming out. So next up, I'd like to invite Deepak Senthilkumar. Deepak is with LexisNexis, market leader in legal analytics. They went through their journey of data warehouse modernization with Redshift. So I'll turn it over to Deepak to talk about that journey. Thank you.
All right, thank you, Manan. Good morning, all. Hi. How many of you here are using Redshift today? Okay, great. How many of you are looking at Redshift as an alternate to the current warehouse that you're using? Awesome. So the people who raised hands, The second, this presentation is more catered towards the people who are looking to migrate to Redshift, but we'll also share our experience in that migration. My name is Deepak Senthilkumar. I manage the data and analytics space within LexisNexis. Who are we? So we're part of the RELX group, which has 4 major organizations. And we fit into LexisNexis legal and professional. And we serve customers in over 130 countries. We have close to 3 petabytes of legal and news data. That's roughly 150 times the size of Wikipedia, all put together. And every 3 years once, we are seeing that is doubling up. So we're getting a lot of data that's getting added as time moves on. To handle this, right, how are we strategizing our approach towards large amount of data? So, we have a lot of different business units and a lot of pockets of data. What we are trying to do is we are trying to create a centralized infrastructure which can be used by all these different business units to collect data into a central place, but also have their own democracy to manage and maintain the data. So that's where we kind of started this journey. And we also want to promote data-driven decisions. And to do that, first of all, we need to get the data in a central place, right? And another challenge with all this is how much money are we going to spend in achieving what we want to achieve? We don't want to, spend a fortune just to achieve this. So we want to build a cost-effective solution as well. And as part of this, we want to build a very strong data culture through hiring, training, teaching our business users how to use the data better. I'll briefly talk about our architecture. And the architecture that I have here, it's not set in stone. There are moving parts to it. As we identify new use cases, we keep adding things to it. But on the far right, or actually far left for you, what you see is the data sources. And we have multiple mechanisms to collect these data sources. We have streaming, we use batch, we use near real-time techniques. We sometimes extract from the source system, or sometimes source system would be publishing the data as a file in another location. So whatever be the mechanism, we have multiple techniques to collect it. We primarily use an extract approach because we want to govern the end-to-end pipeline, but there are other use cases which we are looking at as well. One interesting thing that was announced day before yesterday in re:Invent was direct support from Kafka to Redshift. We are looking to leverage that as well. Once we collect the data, we put it all in a central storage layer, and that's where you could actually see we have a couple of layers there. One is around the raw space, which is we collect the data in the native format that the source system has, no transformation absolutely, just the raw database or the raw data structure that's there in the source. And then we apply massaging to it. We handle lookup values. We normalize the data, aggregate it, generate the facts we want, and then pass it to the data warehouse, and that being Redshift. And in the last, you could see the consumption layer. Primarily, all our analysts use dbeaver for running the queries. And we have started to work on Databricks for our machine learning use cases and notebook type of an environment. Our primary reporting solution is Tableau. And even between this layer C and D, the data storage and data consumption, we are looking to see if we can add a semantic layer. So that's where I was saying this is not set in stone. It's kind of evolving. The reason we are looking for that is business users, when they want to query data, they are writing complex queries to get the results that they need. And that sometimes depends on who's running the query or what type of filters are used. It could give different results. How many customers does LexisNexis have? That's kind of a golden question. And depending upon who you ask or what levers you want to push or what dials you want to adjust, the answer is going to be different. So that's where we are looking to have a single source of truth. Thereby, you could get the same answer consistently. And you could see at the bottom, it's not clearly evident, but the letter E, That's where we have our data governance, security, compliance, privacy, all that. That's a work in progress. We are looking at certain open source tools, and we are also interested about the data zone product, which was announced yesterday. For security and compliance, we have multiple solutions there. From a GDPR, CCPA, data retention requirements that we have custom solutions that we have built. So initially, I was asking the question, how many of you are looking to move to Redshift or considering moving from your current warehouse to another warehouse? So that's the journey we started back in 2020. And it all started with a renewal quote from our on-premise vendor, which was, our hardware was reaching end of life. And based on that, we had to either buy new hardware or look at other options. So when we were looking at it, we noticed the hardware end of life would mean we need to buy hardware. The current solution was not scalable because it had fixed hardware in our on-premise. So when we had things like month-end jobs, when we have to generate invoices, or we want to run certain financial reports which have to run end of year, that's when we need some scale. And we could not really scale up or scale down elastically because it was fixed hardware. And then because of the way the architecture evolved over the last couple of decades, onboarding new sources was taking a lot of time for us. And the production support, operational support, in terms of database backup, database recovery, the DBA side of work that was needed to manage indexes, etc., that was taking a heavy toll on us. And that's when we started to evaluate multiple vendors. And then, after a very detailed POC with around 20 to 25 use cases that we wanted to cover, we decided to proceed with Redshift. So what was the benefits we had with this whole migration? First and foremost, as I was saying, the cost challenge is always there. So we were able to, operate at a cost of 1/5 of what we had with our on-premise vendor, and the maintenance, the production support that was needed, all that was much lesser compared to what we had earlier. And from an architecture standard, what we have decided was, we were previously using an ETL pattern where we extract from the source, do the transformation, and then load it into the warehouse. And that's where there was a lot of time spent on building those ETL jobs. We changed our approach where we changed it to an ELT pattern, which is we extract from the source, load it into the warehouse, and then do the transformation in the warehouse using SQL. And that has proved to be tremendously successful. And we were able to onboard new sources much faster. And as I was saying earlier, we had multiple business units, and each business unit ended up creating their own flavor of a warehouse in multiple different technologies. Once we were able to create the central infrastructure, now we have started to migrate other business units which are across other geographies and other product lines into our central infrastructure. Thereby, there is synergy in not extracting from the same source multiple times. There is a bit of governance there. We are able to leverage on what other teams are doing. There are a lot of benefits with that. And then, okay, we are operating at 1/5 of the cost, but what about the performance? Actually, performance went up. So we got almost 3x gain in most of our reporting queries and ETL jobs compared to what we had on-premise. And the number of production support tickets with failed ETL jobs and data issues and data errors that we were getting earlier, that has dropped almost by 40%. So there were significant gains with this migration. And with all the data in one place, with all the business units kind of migrating over to the central infrastructure, getting to the 360-degree view of the customer to kind of see the full picture of a customer is much easier. So how did we go about this, right? This is kind of my favorite quote by Abraham Lincoln, which is, if you have 6 hours to chop down a tree, spend the first 4 hours sharpening the axe. That was our approach towards this whole migration. Here I have a couple of timelines. The first timeline is basically the preparation work we did, and the second one is the implementation we did. The top line is from 2020 to 2021, and the bottom line is from 2021, 2021 till end of 2021, kind of. It was all 2021. So with respect to prep work, what did we do? We decided on 3 vendors with whom we are going to do a POC. We listed all the use cases we wanted to cover, and what was our approach towards performance benchmarking, and also pricing negotiations. So the first 3 months was spent with all the 3 vendors, where we were running parallel POCs, and we were grading them based on all these different use cases and how complex it was to do the migration. And then from September, October, November, that's when what we did was we finalized our architecture. We built our own homegrown ELT tool, which made it a little easy for us. So it's a very lightweight tool where we just build an adapter for any data source. If it's JDBC compliant, we just take the JDBC compliant driver and connect it with S3. If it was a source like Salesforce or Zendesk or ServiceNow ticket system, right? If it was any other source which requires APIs, we followed the same pattern but built lightweight JDBC drivers to handle our use cases, which was to read from the source and load it into the S3. And once the tool was built, what we did was we looked at our current warehouse and we were seeing what was really needed, what is the usage pattern, and if there is a long tail, we are trying to cut off the tail so that we can focus on a reduced migration scope rather than trying to migrate everything we have. And one big deal for us was we needed case-insensitive collation, which means our end users were not bothering about cases in the filters. So that was a very big deal for us, and that was not there in Amazon Redshift back then. So we worked with the Redshift product team, got that added as a absolute must for us to go into this migration, and they were very supportive of that. As part of the migration, the product team and the account team, they worked with us, got our requirements, and added new features that will support our migration. So we kind of did all this before we started the migration, not when we were in the path of migration. And then another big deal was, we worked with schema conversion tool, which is used to convert procedures, database objects, tables, views, all those different things from one technology to Redshift, right? Whatever be the other database technology. And there were gaps in the tool. So we worked with that product team as well, addressed those gaps, and then came up with, I would say, a 50-60% workable solution with a schema conversion tool. Still, we had to do a lot of manual cleanup, and we ended up building certain Python automation to parse the code and make some fixes so that it's compliant with Redshift. So there was some work that was in progress back in 2021 January. But Redshift has actually started to work with schema conversion tool, and many of those features which we did manually, people have started to add it. One good example is the merge statements, right? We were heavily using merge statements to do upserts, and that was not supported. So we had to convert everything to an update and an insert. But that was announced a couple of days ago. So in future, we'll be using it. And then around February of 2021 is when we came up with our complete inventory list with all the objects that we need to migrate. And that inventory list was huge. It was about 85,000 objects. And that's when we started. So once we started the migration, what we did was, initially we started up with the environment setup. We created a vanilla Redshift instance, which is empty. And then initially we got the database objects moved over, and then we started moving the data. And then slowly we started to get, migrate all the procedures, SQL. And once it was done, the data is already there. And we were syncing the on-premise warehouse and Redshift on a daily basis so that people can actually see the data, not waiting for us to finish the ETL jobs. And as soon as we had the data, we started to migrate the users. So we actually created all the users who are in our on-premise warehouse in Redshift, and we started to train them. I'll talk about that in a subsequent slide, about how we address training. But once we finished the training, parallelly, the ETL migration was also happening, and then that kind of finished around July. And then we focused on migrating all our reports and dashboards. And once we did that, there were bugs that were raised which we had to address. And eventually what we did was we turned off our on-premise warehouse like a trial for a couple of days. And we were noticing like who's complaining. And then we kind of we kept repeating it. And then eventually we said, okay, now we're going to completely shut down our on-premise warehouse. It says here like by October we kind of finished it, but there were a few business units which were kind of running late. So there were like few situations where we had to allow them to use the system, the on-premise system. We completely shut it down in around February of this year. What was our approach, right? The engineering work to do the migration, I would say, is only about 30% of the project's effort. The bigger effort is actually communicating with our stakeholders, analysts, end users. So we had user group kickoff meetings. We had constant countdown timers that we used to send to people, reminding them like this is coming up, your IDs will go off, you need to move to the new system. And we had office hours, which we set up like every day where people can log in and communicate, ask questions. We also, it was a very stressful project in general because, we had a short window, right? Like 10 months is pretty small for a migration of this scale. And we wanted to gamify it a little because, that helped in removing the stress. So we had a couple of contests, which was, bug bounty and give up your ID early and you are into a lucky draw contest, things like that, which reduced the stress for people. And we used Kanban method for our whole project. And one thing that was a very conscious decision was we did not use the query editor feature, which was there with Redshift. We went with dbeaver because it was open source. And we contributed to the community. So we ended up adding around 20 features to dbeaver to support Redshift. Things like file import, bugs around the way they handle non-schema binding views and all that. So there were multiple fixes we did. And training, that's the most critical part. The SQL that people are so used to with the old system is going to be different with Redshift. It's not exactly the same. So we created a very detailed 4-hour session, which talks about how did you do these things in the old system, how are you going to do it in the new system, both from a SQL perspective, process perspective, regular operations that people are so used to doing. And then for sophisticated or advanced users, we had an abbreviated version, which was for 90 minutes. And with respect to the engineering side, we created sub-teams, with clear focus. So there was like a team that was focused on migrating reports. There was a team that's specifically focused on getting the database objects done. And then we leveraged AWS ProServe, who acted as a liaison between us and the product team of AWS, which was also very helpful for this whole project. And we were constantly tracking the status. We had daily reports and monthly reports and all that stuff. Now, what were our learnings with this whole thing, right? First and foremost, we could have had a longer runway considering the scale. However, it could have been something which had more time, is how you always feel with these migrations. And QA and test strategy, I think we had a bit of a gap there with this whole thing, right? As we were migrating the reports, people were finding issues. And what we used to do was we'll reflect the on-premise data back into the cloud warehouse and then fix the ETL behind the scenes. So we had a backup option like that, which kind of helped us to go with this approach. But it's a very risky approach, right? So I think we ended up using a lot of our business users, analysts, as our QA in this whole project. And to prevent them from complaining, that's when we gamified it so that they were incentivized to find the issues and not complain about those issues. If you are migrating from a different technology to Redshift, you need to pay very close attention to how time zone works, timestamps work, and the way the number rounding happens. So one thing we noticed after we did the migration was, financial reporting in our revenue for the month, we saw like tens of thousands of dollars which were not matching up. And that was because of the way the rounding works in our current or in Redshift versus the previous on-premise system, that's different, especially when you do typecasting. So we learned that. And the way Redshift handles isolation, a lot of you might be so familiar with maintaining a status tracking table where if you have multiple ETL jobs, you update the status of the ETL jobs. That's a problem, where you have to handle the logs very carefully. Redshift actually launched a snapshot isolation about 6 months ago. But when we were migrating, we had to pay close attention. And serializable is the default one, so we'll have to pay attention to that. However, having said all that, it all ended well. It was a very successful project for us. We are saving, multiple millions of dollars with this migration. And as part of this journey, we trained around 275 users. We migrated 400 plus users, more than 1,000 reports, multiple ETL jobs in the thousands, database object in the thousands again, and a lot of data. But what's more important is, we did the migration last year, where when we went live, we had around 450 users. Today, we have around 650 users. It has tremendously grown in the last year because of the ease of using this ecosystem and quickly onboarding new sources and all that. What's the future? We are looking closely at the row-level security, serverless, and data share. We have started to use data share. It's been a very good feature that we have been able to adopt and use. Serverless is something we are looking at closely, especially for our dev workloads and non-production workloads. And in cases where we have certain analysts who want to do complex analysis, even there, a serverless is an option we are looking at. And data share, we are currently using it to, at a very minimal scale. But what we want to really do is set up a separate reporting infrastructure, separate ETL infrastructure, and then kind of have data share as a mechanism where ETL jobs will not disturb your reporting layer or ad hoc analysis layer. So that's going to be like a workload isolation setup. So we are working towards that. With that, I'd like to say thank you, and I'll pass it back to Manan. If you have any questions, we'll be waiting outside the lobby.